Hey guys, welcome back. So today we're going to be talking about the electrical system of a Cessna 172 with a G1000. And I have a few references that you can follow along with me during this lesson. So if you want to grab your laptop, iPad, phone, whatever, pull up Google and I'll give you a second to do that. So the first thing you're going to want to type into Google is going to be AVIT media, that's one word, AVIT media. .aero, AERO, .UND.edu, and you should show up with a screen like this. The next reference that we're going to use is the G1000 reference guide. So open up another tab in your laptop and you're going to type in Google static.garmincdn.com. So let's talk about the basic elements that we're going to be covering in the electrical system today. So we have a 28 volt direct current system that consists of an alternating current 60 amp alternator, a 24 volt main battery, and a 20 volt standby battery. There's switches, fuses, bus bars, circuit breakers, and electrical wiring that we're going to be talking about today. Now that might have sounded confusing already because I mentioned that we have a direct current electrical system, but our alternator, which runs everything, is an alternating current. And I won't get too in depth and confuse everybody, but the basics of that is the induced alternating current from the stator coils in the alternator is fed through a rectifier with a bunch of diodes that blocks the flow in one direction, allowing it to go in the opposite direction, converting it from an alternating current into a direct current. So that's why we have a direct current system. So just a couple other things we're going to touch on is what runs the things that you're seeing on your PFD and MFD. We're going to talk about all the things that run your G1000, and that's all going to be in your Garmin reference guide if you want to pull that up on your screens now. So I'm here in the G1000 reference guide on page 2, and it goes into detail about all the systems that run your G1000. So I'm just going to quickly go through, and you can read these in depth, but I'm just going to briefly talk about each system. So the first one is your GDU, which is basically your PFD and your MFD. The two screens get their information by communicating with each other through Ethernet connection. The next one is the GIA. When you are doing your LRU and your GPS receiver checks, this is where you're pulling your information from. This GIA also controls your comms and nav, so all your communications is getting information through this system called the GIA. The next one is the GDC system, which is where you get all of your airspeed, vertical speed, and altitude information from outside air temperature using this system that gives the information to your screen. So I just went over the first page, and the next few pages are more of those systems, and it really goes in depth and explains how things are connected and what is running your G1000. So I'm going to give you guys some homework and continue to read these next few pages and really understand how your G1000 works, because it's super important for all of us to know. Now let's get into your electrical system behind the firewall. So your components, we have the standby battery, as I mentioned, direct current, it controls your essential bus. Your main battery is also a direct current. It controls everything, but only until it dies. Your alternator, which is an alternating current, charges your battery, and it powers everything except your avionics buses. And it powers things while your engine is not running. And you might want to remember this piece of the video for later. So our master switch is a split rocker switch. So the left side of the switch controls your alternator, the right side controls your battery. So when you have the alternator side in the off position, that puts all the load, the electrical load, on the battery. There's two switches because if you were to lose your alternator, that way you can exclude it and all the load will go on to the battery, but only until it dies, which typically they say 30 minutes is the max, but you really never know, so you better hope you don't ever lose your alternator. When your master switch is on, it turns everything on except your ignition switch, because that is your magnetos, it's mechanic, not electric, not a part of this conversation. The next components we're going to talk about are the bus bars and the circuit breakers. So a bus bar, to put it in a simple form, is a common point where voltage can be distributed throughout the system, And it's basically like a power strip. So if you plug everything into a power strip, turn it on, everything's gonna work. If you turn off the power strip, the stuff plugged in is not gonna work. And your circuit breakers protect circuits and equipment from electrical overload. And the good thing about circuit breakers is that they are resettable. Some planes have fuses, ours has circuit breakers, which gives us an advantage because if a fuse blows, you have to replace the circuit. You have to replace the fuse, but with our circuit breakers, we can push them in one time to try to reset it. Now pull out your laptop or iPad and go to the avitmedia arrow.und.edu tab that I told you to open. So let's take a look at our electrical system. We're going to start right here in this gray box. As you can see at the top, it says Power Distribution Module. This is also known as the J box. It's where everything starts, and it's where all the relays are. So a relay is basically where electromagnetic current can flow through from little wires connecting big wires. So as you can see, we have relays here, 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 and here, and it connects the battery, goes to external power relay, battery relay, and then connects to a bunch of bigger things. So a relay is just taking these things, putting an electric current through here, and feeding it through the rest of the system. Kind of confusing, I know. I'm not very good at explaining it, but here's the J-box. So this system is actually a hands-on system, which is why I want you to follow along so that you can press the things that I'm pressing. So let's get started. So as you can see at the top right up here, everything is off right now. So let's turn on our engine and connect our EPU. So just tap it. Now everything is on. Now let's turn our master on. So I accidentally just hit the battery, but this is a good place to start. So when you only have your battery on, all of these blue lines on here, you can see what it is connected to and what is running with your battery. Now let's turn our alternator on. So now all the lines turn red. So without your engine running, this is what your alternator has turned on. Remember at the beginning when I said this is probably a good part of the video to remember? This is why, because now you can see the battery and the alternator are on, and it is connected to everything except your starter and your ignition switch and your avionics buses. Here with your master on, as you can see, you have your electrical bus 1, electrical bus 2, your cross-feed bus, and your essential bus all are running. And this should start to make sense when you think about in your pre-flight, when you turn on your master, you are able to turn on your lights, check your PFD, and put your flaps down. Now remember, we are in a G1000 in this airplane, so let's turn off our master and turn on our standby battery. If you ever wondered what your standby battery controlled, now you know, your essential bus, which this should also make sense when you are in your airplane doing your before taxi checklist and you turn on your standby battery, what comes on? All of this. Make sense? So this should now also help you understand if you were to lose your standby battery, you would lose all of this if you didn't have your master on. So I just turned back on my master and I have my standby battery also on. So everything is running. Now let's work with our avionics switches. So as you can see, we have avionics bus 1 and bus 2. And as you know, your avionics is also a split rocker. So bus 1 is the left side, bus 2 is the right side. And as you can see right here, this symbol is the symbol of a switch. So watch what happens when we turn on avionics bus 1. The switch is now connected and avionics bus 1 is running, which now will turn on avionics bus 2. So as you can see, the switch has been flipped, so it is now connected, and everything on avionics bus 2 is running. So we now have your MFD, transponder, nav2, com2, and your audio panel. So the goal of this is to get you to see how all of this connects and to understand what you would lose if you ever had a failure. So if you had a complete avionics failure, you can see exactly what you would be losing. So up at the top, we can play some more with some things. So let's go to the switches, since I just showed you what switches look like. So we'll turn on all of our lights: beacon, land, taxi, nav, strobe. And as you can see, some of them are connected on your electrical bus 2, some are connected on electrical bus 1, and those are the types of things that you should be memorizing. So as you can see, beacon, landing, nav lights, taxi lights, strobe lights, this is a straight red line. The fuses or the switches are all connected, and for example, the pitot heat is not connected because we did not turn on the switch. Now we can look at circuit breakers too. So for example, if I were to pull my PFD circuit breaker up here in avionics bus 1, this fuse or circuit breaker is no longer connected, it's no longer red, no longer working. Put it back in and it is now working again. So this hands-on learning tool was a great thing for me to use to help me understand the electrical system and learn how things are connected. So some homework for you guys, since we are going to have a commercial check ride coming up, you're probably going to have to explain things. So my challenge for you is to try and memorize what would happen if you lost your alternator. What would you have if you lost your alternator and your main battery and were only running off your standby battery? And last, what would you have if you lost your avionics bus 2? So this was just very basic knowledge of the electrical system. I still need to go more in depth myself, but I hope that this challenged you guys to motivate you to understand what would happen if you lost certain things in your electrical system and to understand how it works so that you can know your airplane.